My small Showman'S engine needs some repairs, and this is part 10, removing all 80 of the LED lights from the Canopy Side Rails. The method that I used seemed to be a simple and quick way of doing the job. Checking the output of the dynamo with a voltmeter by running the engine with the drive belt attached, finding out if it is a DC or AC generator. In the last episode I showed some of the LEDs being removed quite brutally from the side rails. In this episode I show the removal of all of them, using a surprisingly simple method. I've also removed this regulator, which is now no longer fit for purpose, and that's gone in the bin. The quest now is to find another regulator that will fit in the mahogany box that fastens up underneath the canopy. Here we go, it's time for LED extraction time. Initially, I'm only removing the LEDs from just one of the strips. I need to do some tests on the other one before I also dismantle that. In the previous episode, my first attempt at removing the LEDs was to put a pair of pliers on the plastic LED itself and lever it about until it fell off, but this was not a good way of doing it. I've decided to tackle the job from the other side. First of all, by using a small pair of side cutters to initially cut the wires, and then all I have to do in theory is use a pair of pliers and roll back all of the wiring. This was a far quicker way of doing the job, and in no time at all, here I am with just 2 to go. And the bench is now full of scrap pieces of wire and broken LEDs. When I refit the LEDs, I'm only going to use half as many, so instead of there being 80, there will only be 40. Once I'd removed all the LEDs, I rubbed down the mahogany with a piece of Scotch-Brite. Before fitting the new LEDs, I'm going to apply some more varnish to these pieces. All the old LEDs can now go in the bin, and I can move on to the next part of the episode. On my large Showman'S engine, which by the way is currently for sale on the Steam Workshop website, it has ordinary incandescent car-type bulbs. LEDs are quite a different matter. I already know what the output of the dynamo is, it's 30 volts. Here I'm confirming this using a test meter. First of all, I need to run the engine at quite a fast speed. I found something that puzzled me. I initially set the voltmeter on AC volts, and it gave a reading. Then I set it on DC volts in the 100 volt range, and it gave the normal 30 volts DC. When I switched the meter to measure the range of 100 volts AC, I still got a reading of approximately twice as many volts as when it was set to 100 volts DC. I'm sure there must be some electronics experts out there who can illuminate me as to why this is happening. It looks to me to be noise. Or maybe if this dynamo is an AC dynamo fitted with a bridge rectifier to convert the electricity from AC to DC, it's not doing a very good job of it. I'm going to try something to find out whether the dynamo on this traction engine is either a rectified AC dynamo or a DC dynamo. My first impressions are that this device is designed for direct current. When I connect the dynamo to my variable DC power supply, it rotates as I would expect, and it's quite powerful. The next test is to see whether the dynamo will power an external electric motor, which is DC once again. Before connecting this electric motor to the dynamo on the traction engine, I connected it to the power supply, and it runs quite well. And I'm feeding it with 9.6 volts. And when I connect this powerful model boat motor to the output of the dynamo, it spins okay, but not for long. It's actually loading the dynamo so much that the belt is slipping. But it did turn the motor nevertheless. I'm a bit puzzled with these LEDs. When I pushed them too hard, and bear in mind that none of them have the resistors fitted, some of them went out. Only the same colour went out, which leads me to believe that some of these LEDs are lower voltage than others. My initial training many years ago was in electronics, but there were no such things as LEDs in those days. I'll move out of the way so you can see the voltage on the power supply. You'll see that it's 2.97 volts. I've left the traction engine running for a while, just to keep some strange viewers happy who say things like, I didn't subscribe to this channel to see LED testing or things about prostate cancer and recording studios. I just want to see steam engines. I find this a really strange concept. And now it's fun time. I need to see what the voltages are on every LED that I have in a box of LEDs that sort of got mixed up. This is a 12 volt LED and it's very dim. I've had a lot of experience of things that are dim from girlfriends in the past. But they weren't all dim. Look how bright this yellow one is. And now it's time for some useful information. LED lights are usually wired in series with a small resistor. This ballast resistor is used to limit the current and prevent excess current that can easily burn out the LED, with disastrous results, as shown in the previous episode. I used a regulator circuit which gave a constant voltage, but as I've previously shown, that is now deceased. What I'm having to do here is go through every LED in my substantial collection of LEDs to see whether they work. And oddly enough, what I found was most of them were okay, but quite a lot of them didn't work at all, even though I'd never used them in the time I've had them, about 13 years. It's time to look at another regulator, and if you listen in the background, you can hear the steam engine running, albeit on compressed air. I don't like this regulator, it's very cheap and very nasty. This, on the other hand, is far better. A few years ago, I was making a steam plant with a generator, and the plan was to charge my mobile phone. And one viewer got quite interested in the electronic side of steam and started to send me pieces of electronics. But it got a bit out of hand. More and more electronic components arrived from this very kind viewer in Canada. And this thing is called a booker and was one of the components that he sent me. With this device, you can select the input voltage, which in this case, from the Dynamo, it's about 30 volts, maybe 30.5. That's when the traction engine is running quite fast to drive the Dynamo to high speed. Here you can see this device, which is quite good quality. It's made by a company called Drock, obviously made in China, I would think. It's a very good device, it's well made, and it has instructions on the lid, and appears to be very easy to set up. I'll be showing that and quite a few other things in the next episode, including some steam engines. That's it for now. Stay safe, stay healthy. Thanks for watching, and I hope you found it useful. Please take the time to visit my main Steam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.